Neil, Professor Neil Dhara, who basically in one of these chai conversations convinced us that we should write a paper. And then, of course, Jay Thakkar, who's in the conference right there and is going to present half the talk. And so essentially two of them just spent night and basically wrote this paper. And thank you for accepting this, calling us here to share some of the things that we thought, are important, especially for these times when we are talking about engagement over, virtual. Times are different. It's very hard to get the engagement. I think, I don't know, and maybe this is a question, we also have this, I hope we will ask you this question, but in these engagement times, we had this very interesting story that I thought I'll share with you. I don't know how many of you have, and it's a very particular, interesting story which we found working with some of our teachers of computer science over the last 5-6 months since the lockdown started. So, I'm going to tell you a trick of how to get out of a workshop in the most coolest way, and you will not look bad. So everybody, please carry a huge water bottle with you whenever you go to a workshop or a talk or a conference or whatever. And that, theoretically it works better when you're live, face to face. And so the reason it works is because, if you have a large water bottle, you get two reasons to get out of the boring talk. One is, you have an excuse to fill your water bottle and you get out. And of course, if you drink a lot of water, you have to go to, the restroom for a break. So those are two reasons you can, periodically use that. And I thought one of our teachers told us in this workshop that, that what we were conducting, that we did not have to use this trick. So I thought I'll start with that. So thank you so much for calling me here. And what I'm going to do today in the 10 minutes, 15 minutes that I have is to share with you some interesting things that we have, interesting stories and interesting experiences. This is not, talk where I'm going to give you some gyan, but I'm going to share with you some stories and very simple two questions that two sort of rules for the talk is please try to see if you can participate, with all your attention. भाग लीजिए. और भाग लीजिए मतलब दरवाजा खोलकर भागेंगे नहीं. Please participate. And I might also sometimes slip in Hindi, given that Hindi is my mother tongue. So please pardon me for that, and you can remind me and I can translate in English. But when जब दिल की बात करनी होती है तो मातृभाषा में ही निकलती है. अगर आप किसी को बहुत ज़्यादा गुस्सा आ रहा है तो कल्पना करिए इंग्लिश में बात करेंगे तो मज़ा नहीं आएगा. So दिल की बात नहीं निकलेगी. So if I'm going to talk to you from my heart and talk, give you some stories, I might slip in Hindi, and if I do that, please remind me. I will be happy to translate it back in English. So thank you so much for calling me here. My name is Manish Jain. I'm calling from IIT Gandhinagar. Let me change my slides and show you this. From this beautiful campus in IIT Gandhinagar, where we run this lab called Center for Creative Learning, where the goal is to bring back that gleam in the eyes. To make, this is our lab. This is also our lab, and I will stop here with this question and bring you back and take you to item pool. The goal of this lab is to create content which can make learning engaging and inspiring. Absolutely. The only thing that we do here in the lab 24 hours with 10 of our colleagues is to create content which can bring back that gleam in the eyes, make you fall in love with the subject. And with that, I will ask you to go to your internet and ask this question, which will come on your screen. So please go to itempool.com/ccl/live, where you will see this question that should be coming on your screen. What kind of marriage do you have with computer science? I thought this is an ice-breaking question. I want all of you who are here, all the participants to, yes. The screen should be shared. It is there. I can see myself. Yeah. No. Yeah. So I can show myself and I can show the question, and I'm doing this live, sitting behind. See, I'm trying to evade the question. That's it. All you need to do is spotlight the video. There is no need for screen. So we have this interesting technology that we use. Yesterday, Neil and I were discussing about this. So you can go also on itempool.com/ccl/live, or go to our channel, and this is being broadcasted live. Also, you can see it there. I still do not see a lot of answers. Would really request all of you to come and share your answers. Itempool.com/ccl/live. What kind of marriage do you have with computer science? It'll be nice to sort of look at that. Oh, ek answer, of course. See, the good thing about this technology is that I can interact with you live. You are giving these answers, I am seeing it live. The first answer is 18 people are giving that answer. I can only hope, or I can only hope that that is the love marriage answer, but we'll see. Let's look at the answers, and if we can, Gaurav, in just a minute, let's look at the answers, and with that we will start. Okay, let's look at the answers. 20, 30, 30, 35 people have given us the answers. All right. Wonderful. All the answers are right answers. Of course, the first one is love marriage, 23 people. And then, some of them are saying arranged marriage. I thought I will, interesting. 3 people are divorced, and, 4 of them are not interested in the subject, but more in the package. I thought I wanted to, not to say anything about it, but we find it interesting whenever we are working with teachers and students, and, all of that. We would like to sort of, the whole goal of the lab and the work that we do is to see how we can make the content engaging and inspiring. It is particularly important in this scenario where we are doing stuff online. I have no idea whether the students are listening to me or not. They will conveniently say, oh sir, bandwidth kharab hai, barish ho gayi, internet kharab ho gaya, and conveniently there is no way. And so the only answer that I have is to make my content absolutely engaging and inspiring. It was required pre-virtual, but with the virtual thing, it has become even more relevant. And what we did was, and accidentally we, fell upon this strategy of these 3 things, and I'm going to share those 3 things with you. And in the end, also summarize these 3 things that we thought that we have to do for each subject is to, whenever we are talking about a certain subject, we want to create, make the subject boundaries porous. So let me take you to my slides, and with that. There you go. So we started this program called 3030 STEM with that about 3 months ago, and we had an absolutely amazing response for the 13 episodes that we did for this session. We did 13 episodes. Season 1, somebody gave us the idea that you can get a break after season 1. So we did 13 episodes. We had 13 sessions. We had 4 lakh. Let me change my slides. We did 13 sessions. These are all the thumbnails for all these sessions. We had 13 sessions, 4 lakh registrations, 8 million views, and the most kicker was 1 million comments that we had, 60,000 people who submitted homeworks. So never thought that we will get this kind of a response ever to the kind of online program that we're doing. This program was broadcasted live every Sunday for an hour. And I think if I want to summarize, 3 things that we thought we could share with you as to why, we were able to sort of convey what we really wanted to convey. I think the most important thing was that we wanted to convey out of this program was that we are going to unlock the beauty, magic, and mystery of science and math and computer science that is all around us. We are not going to talk about sorting. We are going to play with cards, and in that card, we will do some sorting and understand some. We are not going to talk about force F is equal to ma, but we will start with a cycle and see how a simple cycle shows a mechanical advantage which is less than 1. It is actually, a cycle is not really an interesting cycle. Or whenever we are talking about computer science, and Jay is going to show this from our lab, when we are going to talk about computer science, I'm going to talk about some of the history and context. Why is it that the computer was invented in the first place? Not to play PUBG, of course, or other things. The first computer was invented to break the code of this machine called the Enigma machine. I am very happy and proud to say that this machine, in my opinion, as far as I know, is the only machine, real physical machine that exists in India, in our lab, in IIT Gandhinagar. It took us about 3 months to make this machine, real physical machine. Let me take you to show you the, the picture of this machine. This was about 3 years ago that we made this machine. This machine is called the Enigma machine, of course, and with this episode, Science of Computing, and we had lots of people, give us answers for this machine. So when I'm talking about 3030 STEM, this program called 3030 STEM, which we broadcasted live, and we had absolutely tremendous response. We could never ever believe. Some people ask us, what was the reason why you called it 3030? Interestingly, the day we started, coined the name, Neil was there in that conversation. The number of subscribers we had that day was 3030, exactly 3030. And by the end of the program, we had 160,000 subscribers. And I think there were some lessons for us. It is absolutely important to make the content engaging and inspiring, but I think we learned 3 lessons, and I'm going to share those 3 lessons with you in just a minute. And those 3 things were, you can make the content engaging, and how do you do that? I think the first thing that we thought, and we thought we'll share with you, is to see how we can break the subject boundaries. When somebody is digging deep, and miners do that, when they go dig deep in a hole, they will also dig these side holes from which they can get the oxygen. So if I'm talking about computer science, I also want to talk about the history. I also want to talk about the context. I also want to talk about whether it is beneficial for me to even do this or not. What is the larger purpose of the technology that I'm working on, and things like that, and I can decide how much of that to bring, how much of the subject boundary should I make porous first. The second thing that I'm going to do is to create a narrative or a story around the whole thing. You might have seen this film called Three Idiots, and this guy who wrote the book is great, right? He wrote this book, Chetan Bhagat. I forget the name of the book. I have not read it. But the person who actually wrote the screenplay, put all the humor and this and that. A good friend of mine, Sudarshan from IIT Roper, he says this, that you have to add nav rasas, and I don't think she added nav rasas. We probably added 1 or 2 rasas. We wanted to make sure that there is something in it for every single person. We were audience inappropriate in some sense, right? Somebody asked us, who did you create this program for? And we said, we created for inappropriate audience. And it's a pun on words, but what we are trying to say is there was something in it for every single person, for a 3-year-old who were watching. And in fact, the feedback that we got for those programs, I'm going to show you in just a minute. Right here, somebody is saying that yes program ki hame Ramayana प्रतीक्षा रामायण सीरियल के जैसे रहती है. And these are some of our teachers who are saying this. लगता है इस वीडियो को निकालने का ऑर्डर दिया गया था, लेकिन लगता है इस बार सरकार ने कुछ अच्छा काम करा है. दिस प्रोग्राम इज लाइक अ जीवन रक्षक घोल. एनसीईआरटी टेक्स्ट बुक कमेटी में हमें डाल देना चाहिए. एंड फीडबैक थिंग्स लाइक दैट. Reasoning and research, this is from and the best thing was that the reach that we had with this program was phenomenal. Every single state in India we had viewers from. Registrations, 4 lakh registrations from every single state except I think Lakshadweep. We missed on that. So that was the idea. And if I were to summarize what is it that we did in just one slide, it is right there. This is something that we tried to do. The core of this program, the core of what we did was our activities. Absolutely amazing, interesting activities, whether it is cards, whether it is a cycle, whether it's vegetables. The most popular episode of 3030 STEM, and people who really liked that, I think we had about 2.5 lakh views, was looking for a sine wave in a cucumber. Or magically looking at the peel of a cucumber and seeing how the pie vanishes. If I have time, I would really like to show you that. You remember, if you take a cucumber, normally you take a cucumber and make a slant cut, you see an ellipse. But the most magical thing is if you take the peel off, it's a sine wave. In fact, 1 minus cosine of x. And if you cut that, you take the area of that peel, it is pi. But if you take half that peel, the pi magically disappears, even though it is circular and curves around the whole cylinder. Some of the most interesting things that we did was in this, and so what we are trying to say is this: the heart of what we did in 30SEM was this absolutely engaging and inspiring activities. And then around that was this story or the narrative that we tried to build around. This is, I would call the screenplay or navrasa or whatever, humor, story, context, all of that. Of course, what we did was also chose a decision that we made, that we are going to do this program in Hindi. There were a couple of reasons. One, of course, we wanted to convey that interesting things can also happen in Hindi. It doesn't have to be English. Most interesting content on the internet, if it is related to STEM, science or technology, engineering, mathematics, computer science, is largely in English. And we wanted to convey that अच्छा काम हिंदी में भी कर सकते हैं. And we also wanted to make sure that this belt, this Hindi belt, which sort of feels let down, gets something very engaging and inspiring. And that was one of the big things, one decisions that we made. I don't know how, we decided upon that, but interestingly we did that. And something that we made sure was this live interaction. That this technology itempool.com, using which we can interact live with our live with the audience. You give the answers, we were interacting live. That's a huge the feedback that we got from the audience was that these 6 and 7 questions that you give on, and the way you can think about all of this is also, if you go look at these episodes, by the way, those episodes, if you want to see, just Google 3030 STEM and you should be able to see all of those episodes. The feedback that we got from all our audience was that, and you can see it in the answers. If you go, you can also do these questions and answers now. Even when the episodes are not live, they are on YouTube. The answers to all our questions, these were very non-intuitive things. And so you can game this thing by saying, I'm going to give you the most non-intuitive, non-obvious answer, and that will be the right answer. The point I'm trying to make is that the questions that we gave were absolutely, made you really think. Absolutely made you think. And then each episode was followed by, let me take you to the slide. Each episode was followed by a homework. And this homework was, a link to this homework was given in the description. So in some sense, and this had about 8 to 10 problems. Related to the episode, 8 to 10 things related to the episode, but not really, let me see if I can get my iPad here. Related to the episode, but not, but it would really make you think for weeks. The kind of problems that we give will make you think for a week. For instance, if you imagine you have a cycle, or let me show you this beautiful trick, because all of you are related to computer science. Let me just do this trick with you. This is the kind of things that we were doing, in 3030 STEM. I'm just trying to find my one of my sticks, if I can. Well, now somewhere. Yeah. Okay, so what I'm going to do is, by the way, I don't know if I did that. Let me show you this. Take a minute, take half a minute, if I can say break, and show you this absolutely amazing thing that we did in our lab. Where is this ACM? Oh, there you go. And for that, I will start this film. Please go to, this film will start just in a minute. I hope you can see this film. Okay, let me start with this again. Yeah, so this is what we made for ACM. This is A, this is C, this is M. This is a single object ACM. ACM comes out of a 2D paper and becomes an object, and it of course fits in all these 3 things. And our colleague Tapas made this. This is my A, C, and M. It will fit exactly in all these 3 letters. We were really inspired to do this based on the work done by Eric Demain, and I'm going to show you how compute can also come out of paper. And let me just do that activity right here with you, and I'll show you card tricks, and then take you somewhere else. So we were really inspired by this, this person called Eric Demain, who is interestingly the youngest professor of math. Who is the youngest professor of math. He's a professor of math and computer science at MIT, and he never went to school. School कभी नहीं गए. So teacher and he and his dad would go around the country in Canada and do this lot of activities with paper. And then when he finished, when he was about 12, 14, 16, 17, 17 maybe, whatever, he decided to, less actually, of course. By the time he was 20, he was a professor at MIT. I don't know when, but he decided to do his undergrad directly. सीधे कॉलेज में चला गया. वहां पर किसी ने नहीं पूछा कि पुरानी डिग्री 12वीं का सर्टिफिकेट दिखाओ. So he went and did his undergrad, then he did his PhD, and then immediately MIT asked him to come and teach at MIT. Nobody asked him, show me the class 12 certificate, because he didn't have any. And he absolutely interestingly made this for those students who are here. Let me show you what he did, which really inspired us. I will just take a minute in my overhead and show you. What he did was he proved that if you have any closed polygon or closed shape, I'm trying to make an elephant here, and sorry about this, because I think I have made a 3-legged elephant. Nonetheless, it solves the problem. It doesn't matter. 3 my Yati is not good. But what he showed and proved, that if I have this elephant and if I have to cut it out with a scissor, I can go here, then up like this, top, and this like all of that, and then room by things. Except what I can do, I can fold the paper, if it's a closed figure, in such a way that this whole object comes out of paper in a single cut in one direction. एक बार कैंची चलाएंगे एक दिशा में और पूरा सब कुछ बाहर आ जाएगा. This is the algorithm that he devised, and we extended his algorithm to do this for all letters of the alphabet. And so I have this compute in my hand, and I'm going to move this कैंची, this scissor, in a single cut in one direction. All right, right in front of you, and let's see what happens. I think compute will come out of 2D paper. Let me. This is a little thick. So let's see what happens. And there you go. The letters are coming out, and this is the rest of the paper that is down. I will take you here on my overhead and show you what happened. Overhead. These are 7 letters that I have right here. Let's open them up one by one and see what happened. Okay, so this is my first letter. Of course, I didn't cut it exactly on the line, but let's see. So this is my O of compute. This is M of compute. All right, this is M of compute. Oh, C of compute. Sorry about that. C of compute. And I think one of them might have gotten P of compute. This is E of compute. All right, and this is single cut compute. Single cut compute. This I think is T of compute. All right, this is P of compute, and we will have Jay take you to the lab and show you a few things. I'll just show you another activity, the card activity. Oh, this is U. I'm sorry. P U C O, and this must be the M, which got cut badly right here. So let me see if I can salvage it a little bit. Yeah, this got messed up, but you have everything else except the M. COMPUTE. Compute comes out of paper, right here. So this is a single cut compute. Now, this is what inspired us. Single cut compute. So we did single cut ACM and single cut compute, and the whole goal of all of these things is to see, and it's a beautiful algorithm to sort of see how I can fold a paper in such a way that with a single cut the whole letter comes out, no matter which, and we took this algorithm and did this for all letters of alphabet. So you can potentially write all your names, the name of your college, the name of yourself or whatever, and you can become single cut. In fact, interestingly, in Jay's my colleague Jay, when he was getting married, we gave him a single cut, Jay weds Shilpa, this whole sheet of paper, you do single cut and it comes out. All right, so like I said, the whole goal that we were trying to do, the whole deal of what we try to do in this lab is to create this content. We have created 200 such activities out of MDF, out of wood, out of these toys, thousands of activities, games, stories which can bring back the joy in the curriculum. So let me just do this simple thing. I have these pack of cards right in front. I have these 26 English letters, right, English alphabet, 26 cards right here in my hand, and these have holes. And let me see if I have to let me take you to overhead, that is better. So I have these cards with me, and I can, you see they are not sorted, they are not in order. And if I have to do with by brute force, I will first find A kahan bhag gaya? Oh, A nahi likha. Let me just see if I can find my A. A is not to be found, maybe A is missing. So, oh, there you go. So I get A, keep it here, then I do B, and so on and so forth. It is very clumsy, except what I will do right now is just do a very simple, cute trick. And what I have here is I will do, and let me put this A back in the middle somewhere. Okay. So what I'll do is I have these 5 holes. I put this thing in my, a wire inside, and pull this out, okay, and keep it here. And then I do the same thing for the next hole. Put this in and take this out, put it here, then do it for the third hole, same thing. I hope you can see what is going on. There is no cheating. And 3, and then I do this for the 4th hole. Fourth hole, and then I do the same thing for my 5th hole, and hopefully we look at the results. Okay. All right, let's see what happens. There you go. I have A, B, C, D, E, F, G, H, I, K, L, M. Oh, X. I think 2 of my cards are missing, but nonetheless, these are sorted. These are all in order. And the reason that happened, or the reason it worked, is absolutely wonderful. What we did was we had these 5 holes right here, you see, and these holes were of 2 type. And so if I have 26 cards, I'm basically trying to sort, and this is a little different version of radix sort, except what is happening is, and if you're trying to find out why it worked, the answer you figure out. But if I have to sort of summarize that in just a minute, it is basically when I put this thing here in the smallest hole, I am sorting the first digit relatively. So I'm sorting the card 0, 1 relatively, 2, 3 relatively, similarly things like that. But which means that 0, 1 relatively are sorted. 0 will always be before 1 because 0 is the one which has no hole. So I pull it out. And 1 is the one, this is empty. So 0 will always be before 1, 2 will always be before 3, and so on and so forth. I mean, 0 and 2 might be before 1 because, 1 can be at the back. But 0, 1 is relatively sorted in the first go. In the second go, the 2 bits are relatively sorted, which means 0, 1, 2, 3 is relatively sorted. And similarly, 4, 5, 6, 7 is relatively, with 3 and like so on and so forth. And in the last one, of course, all the bits will get sorted. So please try playing with this. And then what we did was we extended it. We said, why have 5 holes? Why not just 3 holes? And 3 different kind. In fact, you see here, we have 3 different kind of holes. This hole is completely done. This has a small opening, and this has full opening. And when we did this activity, we had about thousands of people across the country sending us the results. And with 3 holes also you can sort it. Now this, if I say, is some sort of, I'm using some sort of binary here to sort this. This one, I'm using some sort of ternary. And in fact, imagine, you have, similarly, if you had, let's say, you do this based on quaternary, if and you can have and the number of times you need to put this stick in is also, you can figure that out. Base log. So log of 3 here, if I have to do, I have to put my stick 5 times. Here I'm doing each hole but 2 times, so 6. So in 4 I have to do 3 times log 4, things like that, right? So I can basically design my card game and show radix sort by doing this activity using either 5 holes or 3 holes or 2 holes, or if I have 52 cards and I have 52 different kind of holes, I can use just a single hole itself. So that is interesting. Interestingly, while doing this episode, we realized that Hindi alphabets are 52 and English is 26. So Hindi is exactly double the number of alphabets per and if you use 4, you can do all of that sorting with 3 holes in base 4, 4 holes in base 3, and 6 holes in base 2. So absolutely, please try this activity on your own. Please have these cards, and if you need some help, send us an email. cli@iitgn.ac.in. cli@iitgn.ac.in. Things that we would want to. So we have done absolutely amazing toys in our lab. Jay, I'm just going to transfer to you in just a minute. Let me show you one interesting activity. Simple thing, yet very interesting. I have these cubes. Each of these cube has 4 colors. 4 colors. Which means some of the colors will be repeated on the faces. And your goal is to have these 4 cubes, randomly 4 colors on 4 cubes, put them one on top of the other, such that all 4 sides have 4 different colors. So, of course, this is not right. You have to bring the blue here, and you have to bring the red. So this is done. This is done. This side is done. However, this side is not done. And this side also is not done. And the 4th side is also not done. So what sort of algorithm, what sort of process you will design or create, and a very interesting graph theory problem. So if I'm going to do that, I might as well start with this. That brings something physical. Remember 3 things that I was saying: make the subject boundaries porous. Second, give them something that they can relate to, touch, feel. Give them things from the regular life cycle that I see every single day. I'm going to use that as a context, as something to bring the attention together, to get you involved. And then I'm going to take these tangents and talk about whatever else that I have to talk about. I will talk about mechanical advantage of a cycle being less than 1, which means that cycle actually is not a machine. You need to put more force to move. You have to design a cycle where mechanical advantage is greater than, which is real definition of a machine. For those who have not, please go watch this episode on what is a machine, 30-30 STEM, or watch the movie 3 Idiots, where this guy says what is the definition of a machine. Anything that makes the ye machine hai, zip up machine hai, this, that, whatever. We thought we will add another definition in that machine. One, of course, it makes our work simpler, but it should also be something that helps the humankind. सिर्फ ये machine बनाने के लिए. Done. Let me just take you here. Thank you for asking this question, Jay. If you are ready, Jay wanted to show the real machine from the lab. I will just say you can go to this. You can just search for CCL, IIT GN, Center for Creative Learning, IIT Gandhinagar. Lot of the stuff that we have done is on the email, is on the internet. So on YouTube. Oh, I'm sorry. I'm not. Yeah, overhead. Oh, not overhead. iPad. CLI@iitgn.ac.in. This is the email. This is our website. Website is ccl.iitgn.ac.in. In fact, that is the last slide, if I can. Where is that slide? Got missing. Here. So this is our email. This is our channel. This is the 30-30 STEM program. And this is the Facebook. So your question was, what kind of things, other sorting activities? We have done this. There are a couple of other things that we do for, lots of, quite a few things that we do which are specifically related to computer science. So please go to internet and or our website and see. And of course, we will be very interested to show you a brilliant animation of this Enigma machine. This is something that gets used for recursive backtracking algorithm. You can apply and get the answer, or you can use graph theory. Another trick right here. This is called up it up. You use these cubes and you can only roll them in this 8x8 grid such that the bottom thing comes up. This is the bottom. This is the bottom logo. This is the top logo. This is a reminder of an old game that we used to play when we were young, except this is a 3D version of it. You are supposed to just roll this dice and bring the bottom thing up. And the only person to have solved it in 36 moves is either a person called Biren, who is in our security staff. Recursive backtracking algorithm, 36 moves. If you can solve it in less, please let us know. Jay, can you just take it to the... Yes. I thought we started late. I just wanted Jay to just share this Enigma machine with you. Only machine in the whole of India. जय उठा के कैमरा उठा के पास ले जा मशीन के अपना लैपटॉप